Hi everyone, my name is Bobby and I'm the instructor and program manager for the Sustainable Agriculture program at Highline College. And Justin Tylon has asked me to give a guest lecture for your class. So today I'm going to briefly talk about sustainable agriculture and why it's important and what can be done to improve the sustainability of our food supply chain. Our food supply chain is made up of many different components, but in general, there are producers, which are the farmers that actually grow and harvest the raw food that we eat. There are processors, which take the food, the raw material, and then somehow physically or chemically change it into a value-added product that they can then sell for more money. And then there's distributors, and these are folks that collect the food or the value added product and then transport it to a wholesaler or a retailer. And wholesalers are companies or an individual who sells a product in bulk, typically to a retailer. And typically the consumer doesn't ever come in contact with a wholesaler, but you're more likely to come in contact with a retailer, which tends to sell products and goods in small quantities. And consumers are all of us, people that purchase a product for personal use. And so throughout the scientific community, by and large, uh, there has been an agreement that there are three pillars of sustainability. In order for something to be truly sustainable, it has to be economically sustainable, has to be socially sustainable, and environmentally sustainable. And essentially what this means is that, first of all, the company or the person has to make money to continue what they're doing. So money is important, but it's not the only aspect. They should also be socially sustainable, meaning that the product or service that they are selling should be good for humans and for communities. And then there's the environmental component, which most people are kind of familiar with, and that's that a sustainable business should not do harm to the environment or deplete natural resources. And so, what does farming have to do with sustainability? Well, first of all, 1/3 of global greenhouse gases come from agriculture throughout the world, and about 1/3 of these greenhouse gases from agriculture come from raising livestock. Um, Livestock tend to produce a lot of methane as they digest food, and that actually makes up a very large portion of greenhouse gases in our atmosphere. Another source is through tilling of the soil, and tilling is the process of breaking up the soil into very small particles, which is really sought after by farmers and by plants as well. Plants like really loose soils to spread their roots out. Um, but the only problem is that when you disturb the soil, all of the carbon that's been captured from these plants that are growing, that have decomposed and turned into compost, has then been released into the atmosphere when you till the soil. The last one is actually pretty surprising to most, and that's wetland rice. So wetland grown rice um, also produces methane caused by the anaerobic bacteria that survive in the soil. Um, and similar to the anaerobic bacteria in the gut of the livestock that tends to create the methane, it's kind of similar to that. So those are the three leading causes of greenhouse gas from agriculture. Agriculture is also the most common cause of ocean dead zones, and this is caused by a process called eutrophication. And essentially, what happens with eutrophication is there are excess nutrients in water bodies that typically come from farms, and this can happen through erosion or nutrient leaching through the soil. But either way, they end up in the water, and what this causes is a huge surge in algae blooms. And this algae, from this picture you can kind of see here on the right, the algae forms this blanket on the surface of the ocean or a lake or a pond. And essentially what that does is blocks out the sunlight from penetrating below the surface to where all of the plants that create the oxygen for the aquatic life survive. So the plants that are producing the oxygen die because they don't get sun, and because there's no oxygen in the water, the rest of the aquatic life dies as well. So the scientific community has labeled these, given them a name of dead zones. And this is another picture to the left here of what a large algae bloom can look like over the ocean surface. And then to the right is kind of the effects of these algae blooms if they actually lead to a dead zone. And this is a lot of fish that have been sort of swept up onto the beach that can no longer survive in these waters because there's no oxygen present. And the largest dead zone up until recently was the Gulf of Mexico dead zone. It's still the largest dead zone in the Western Hemisphere, but it's mostly caused by agricultural runoff from excess fertilizer, typically coming from synthetic fertilizers, and it's the size of the state of New Jersey. So it's not a very small region. This is a big impact on the ocean. Then there's the environmental harm that can come from transportation of food. As you might have guessed, most of the world actually lives in cities now. That's a pretty new thing. But the challenge with living in a city is that it's difficult to grow a lot of food in a urban setting. So what that means is we have to grow food in a rural area and then transport it very long distances to get to your grocery store. On average, the food that you buy in your grocery store travels about 1,500 miles, and for every 1 calorie of food that you consume, it takes about 10 calories to produce and transport that food to your grocery store. So there's a lot of fossil fuels that are used in bringing you food. Agriculture is also responsible for 70% of freshwater use in the world and about 80% in the United States. And this is largely due to irrigation, and not just irrigation, but the type of irrigation. There, in many parts of the country and the world, we still use a form of irrigation called flood irrigation, which essentially floods your fields with water, and it's very low efficiency, about a 40% water use efficiency rate. And this is something that has actually been used since the dawn of agriculture about 10,000 years ago. And the reason it's still used today is that in areas where water is free or cheap, and in areas where farmers don't want to spend a lot of money to irrigate their crops with high-tech equipment, they sort of divert to flood irrigation. The picture on the right here is an image of center pivot irrigation circles you might have seen if you're flying over Washington State, for instance, or California. They're very common. And these are basically large circles that have an irrigation boom that irrigates the crops 24 hours a day. And the thing to keep in mind with all of these areas is that crops are typically grown in areas that are not well suited for farming without irrigation, meaning that they're usually very dry and arid regions of the world. And in order for those crops to actually grow, they need some form of irrigation. They can't rely on rainfall, which is very productive, but it can also be very wasteful. Another thing to think about is that 981 million acres in the world are considered salt affected, and these could be salts similar to what you have on your table that you put on your eggs in the morning, such as sodium, but it could also be in the form of calcium, magnesium, and other minerals. And these essentially come from using synthetic fertilizers in very dry regions of the world. And so what happens is these synthetic fertilizers are put into a salt formula because they're very stable and they're lighter than using some of the organic fertilizers that are available. And they work great until the point where salt starts to accumulate in the soil surface, and at that point there's really no solution if you are dependent on rainfall in dry regions that are growing things like grain, or if you're growing in a dry region that you irrigate and you're pumping from a well that has been affected by salt from your fertilizers, then it's really difficult to solve this problem. So, I briefly talked about some of the problems that agriculture causes, but the nice thing is that there's hope. There's lots of solutions that are already in reach that we just need to put into place. And it's not going to take a whole lot to make some of these changes, or at least steps towards these changes. It just kind of takes farmers learning about them and seeing the benefits and moving in that direction. So, for instance, drip irrigation is a pretty inexpensive irrigation method that has a 90% water use efficiency that it basically irrigates in a very precise fashion. There's also compost that is an organic source of fertilizer that does not contain a high salt content that will not cause salt accumulation in your topsoil. To reduce transportation emissions, you can buy locally at your local farmer's market or from a local farmer or CSA program. And then there's soil testing. Even if you do use synthetic fertilizers, you would be better off to test your soil each year to make sure that you are not over fertilizing your crop and causing eutrophication. And then there's some more complex types of methods that can be used as well. The picture in the lower left-hand corner here is a no-till seed drill, which is commonly used in the Palouse, the eastern Washington region. And essentially what this does is it plants a seed and plants fertilizer at the same time without tilling the soil and releasing carbon into the atmosphere, or at least not as much. And then lastly, there is a very famous ecologist named Alan Savory who has spent his life trying to solve desertification. And essentially what he claims is that if we were to take every livestock that we grow in the world and we were to move them to grassland plains and move them in a migratory fashion, similar to some of their relatives, like the wildebeest, that would alone would trap enough carbon in the soil to reverse soil or atmospheric carbon to pre-industrial levels. So there's lots of different ideas out there, and these are just some of them, but I hope that you will kind of consider them and find some interest in them, and I will talk more about them on class on Monday. All right, take care.